Welcome back to our curling rock collision question. And you'll remember that we had curling rocks, they were glancing off one another. And the overarching topic that we're talking about is conservation of momentum. And you'll recall that I talked about this rock glancing and going on an angle, and this one also glancing and going on an angle. And I also tried to promise that I would do this with no numbers. So I'm going to give you the no numbers physics behind it. And hopefully you like that. And hopefully you'll be able to want to flip the page. And once I give that, I will challenge you with giving you one value. And those of you who are in my class, based on this qualitative stuff, you should be able to give me the answer I'm looking for about the resultant angle that the other one glances off and all that stuff, okay? So let's finish this page with my no numbers summary. So we have I'm going to have a seat here and go down a bit. And follow with me, don't just jump around because it's gonna maybe make you nervous or whatever. First of all, we have the initial momentum. All the momentum at the beginning was in the east direction. There was nothing going north, nothing going south, out of the page, up in the air, nothing like that. It was just all headed east. That was where all the momentum was heading. So the initial momentum, I'm going to just draw a red line that represents all the initial momentum. In fact, that red line that you see right there, I could make a scale diagram and do the math behind that and all that stuff, but let's just talk about it instead. This total momentum represented by the red line is going to be conserved. And it's broken up, however, into two parts. It's the momentum from the second rock and the momentum from the first rock. So that I put some dots in there, red dots, just to indicate. So in other words, the total initial is the total final. Look at this. Here's the east momentum from rock 1. So there's rock 1 up there. That's the east momentum. And the east momentum from rock 2. There it is right there. Actually, I really should put a number in there, so I'll call it M2, okay? So all the beginning splits up into two parts going this way from rock 1, rock 2. Okay, so that's we'll say the X direction taken care of. Now, what about the initial momentum going other directions? And in particular, I'm talking about the north-south direction. Well, there was no momentum. That's why initial momentum in the north-south direction is 0, because there's no velocity going any other direction except for east or positive x along the positive x-axis, whatever way you want to look at it. But we know that we've got movement, and this particular diagram represents not just the movement, but the momentum of that rock going down, and the other one is going up. So we have a total of 0. But how do I count for these two purple arrows? Well, I see that rock 1 is going up by a certain amount. And again, I could do this, but with a scale diagram. And rock 2 has to be going down by the same amount so that they equal 0. And that's it. There's nothing more to understand. All the calculations that you would get in a question like this come from those principles without a number being spoken. Okay, so let me flip the page and I will challenge you with a question. So if you're just watching for fun, whatever, I hope you had a good time. And if you want to carry on, let's just make up the question here. Let me do this. Okay, so suppose M2, also 10 kilograms, moved at 1.6 meters per second at an angle of 30 degrees to the center line. Now, in this case, you know the center line is also considered the x-axis. What would be the angle that M1 took after the collision? And just because one split off at 30 degrees doesn't mean the other one does. Okay, that doesn't cut it. So recall, we are in two dimensions, so momentum is conserved in all directions. And let me just, I think I have enough information here. We have, I'll just get you started. We have, let's see, M2 is moving at 1.6 meters per second, so I'm just going to draw M2. Let's see if I get this on the other page. Oh yeah, I do too. Let's flip the page. There's the situation. I've got M2, it's been hit and it's glanced off the center line at 30 degrees. Can you see that? I'll darken that up a bit. And it's going 1.6 meters per second. And so this is going to, I'm going to label this V2 final is equal to 1.6 meters per second. Let me add this as well. P2 final. So in other words, the momentum of P2, the momentum of this rock. What is the momentum again? Momentum is equal to mass times velocity. So that means I've got 10 kilograms times 1.6 meters per second, and that is in the direction of 30 degrees south of east. 30 degrees south of east. That's what I want you to determine. I want, from all what I've said, I want you to determine the angle that this guy goes. Okay, and I'm going to leave it at that. And if I find out that I haven't given you, no, forget it. I've given you enough. So take care of that. And if you want to work it out, work it out. I'll see you on the next video. Thanks.